Welcome to episode 12 of the Head in the Clouds video series. I am Ken Hartman, a SANS certified instructor and content creator for the SANS Cloud Security Curriculum. Today's episode is titled, Are Snapshots of Cloud Virtual Hard Drives Forensically Valid? A few years ago, I heard a talk by an engineer at AWS who said that one should not rely on a snapshot of an EBS volume for forensic evidence in a court case because you would not be able to get an engineer to testify in court regarding the proprietary algorithm that is used to create the snapshot. And that's the wrong way to look at the issue. The proper approach is to use the same technique that would be used with a hard drive from a laptop. You compare the cryptographic hash of the copied volume with the hash of the original volume. This episode demonstrates how to clone a virtual hard drive in AWS, Azure, and Google Cloud Platform. Next, we attach the cloned volume to a second virtual machine designated as a forensic workstation in each of the clouds. To demonstrate that it is a true copy, we will compare the SHA-1 hash of the source volume with the SHA-1 hash of the volume created from the snapshot of the source volume. Let's take a look at each one of the big three cloud service providers, starting with AWS. For this episode, we will be using the consoles, as many of the episodes previously focused more on the command line interface. What we'll do is we'll launch two Amazon Linux EC2 virtual machines in the same availability zone of a region of your choosing. A T2 micro instance type is fine with a single hard drive. All of the default settings are fine. Once the instances are launched, we'll tag one with the name Test System and the other with Forensic Workstation. Then we're going to SSH into both of the virtual machines. So as to avoid confusion regarding the role of each virtual machine, we'll change the host name using the command sudo hostname name, where name is either test system or forensic workstation, depending on the virtual machine. Then we'll run exec bash to update the prompt with the new host name. Once we've done that, we're ready for our demo. In the SSH session with the test system instance, run the lsblk command and observe that there is a single EBS volume, xvda, with one partition, xvda1, and that the partition is mounted to root. In the EC2 web console, click Volumes in the left-hand navigation menu. Note the availability zone of the two existing drives, and then click the blue Create Volume button. Select the same availability zone for the new volume as the existing two volumes that was just noted. Change the size of the volume to be 5 gigabytes. Leave the snapshot field blank and do not select Encrypt this volume. Create a name tag for the volume called Data. Having done that, click the blue Create Volume. Next, let's attach this new volume to the test system instance. Select the data volume and then choose the Attach Volume option from the Actions drop-down field. A form will pop up and select the test system as the instance to attach the volume to. Leave the other defaults alone and click the blue Attach button. Back in the SSH session with the test system instance, run the lsblk command and observe the changes. Note that the volume has not been mounted and is not even formatted yet for that matter, so let's do that now. And now, if we run the lsblk command, we see that the new volume has been mounted. And now, let's add some sample data to the volume. Next, we will calculate the SHA-1 hash of our new data volume. But before we do, let's unmount it to prevent any accidental changes to the volume subsequent to the hash calculation. The results will look similar to what's shown on screen, But note that your hash will be different because evil3.txt is filled with random data. Next, we will clone the data volume by making a snapshot of the volume, and then we'll make a new volume from the snapshot. In the EC2 Web Console, select the data volume, and then choose the Create Snapshot option from the Actions drop-down field. A new form will appear. Enter snap of data volume for the description, then create a tag with name set to evidence. To see the new snapshot, click Snapshots in the left-hand navigation menu. Once the status of the snapshot shows that it is completed, select Create Volume from the Actions drop-down field. A new form will load, and be sure not to change the size of the new volume to be created. If you do, the SHA-1 hash will not match our reference data volume from the test system. As before, be sure to select the availability zone that the other assets are in. Tag the new volume with a name tag of evidence and click Create Volume. The process of attaching the evidence volume to the forensic workstation is similar to the process we followed to attach the data volume to the test system. Select the evidence volume and then choose the Attach Volume option from the Actions drop-down field. A form will pop up and select the forensic workstation as the instance to attach the volume to. Leave the other defaults and click the blue Attach button. Now, if we run lsblk in the SSH session with our forensic workstation, we can see that our volume has been attached. Now, for the moment of truth, time to calculate the hash of the evidence volume. And as you can see, the SHA-1 hash does indeed match the hash of the data volume as calculated on the test system. Thus, we can conclude that the process of making a snapshot of an EBS volume and making a same size volume of the snapshot is a true forensic copy. Note that we could have made a snapshot of the boot volume and could have made a clone of it. The problem with that is the volume would be constantly changing unless it was unmounted. And if it was unmounted, we couldn't use the operating system to calculate the SHA-1 hash. In practice, we simply make a snapshot of the boot volume or any other volume as needed and trust the integrity of the snapshot. In AWS, each snapshot is given a unique ID, and that ID is never reused. Recording that snapshot ID should be treated the same way that recording a hash is treated during an incident investigation. Of course, one should also document the hash of the cloned volume when it is attached to the forensic workstation before other analysis is performed. Once the hash is calculated on the forensic workstation, the volume can be mounted read-only and analyzed using various forensic tools. Note the read-only option passed into the mount command. Next up is Azure. The process for Azure will be similar to what we just did in AWS, with the exception of UI differences and some terminology. Okay, we will launch 2 Azure virtual machines, one at a time, in a region of your choosing. Put them in a new resource group named HITC. Use the Ubuntu 20.04 Gen 2 image and name one Test System and the other Forensic Workstation. Select a standard B1S size virtual machine and generate a new SSH key or use one that's already stored in Azure. All of the default settings on the disks, networking management, and advanced tabs are okay as is. SSH into both virtual machines. In Azure, the hostname is already set for us. In the SSH session with the test system instance, run the lsblk command and observe that there are 2 volumes, SDA and SDB, and that both volumes have partitions. Let's add a new data disk to our test system. Back in the Azure portal, while viewing the test system virtual machine, click on the disks in the left-hand navigation menu. In the page that loads, click the Create and Attach a New Data Disk button in the middle of the screen. Name the new disk Data and set the size to 4 GB. Then click Save. Although this page will allow you to provision a disk of any size, you can only make a disk from a snapshot that matches one of the sizes listed on this web page. As we noted in AWS, if the clone drive is not the same size as the source drive, the SHA-1 hashes will not match. Back in the SSH session with the test system VM, run the lsblk command and observe the changes. We can see that the new volume is SDC, and as with AWS, the volume has not been mounted and is not formatted. Let's do that and add our sample data as before. Next, we will unmount our data volume to prevent any accidental changes to the volume and calculate its SHA-1 hash. The results will look similar to the following, except for your hash results will be different. Following our test process, we will clone the data volume by making a snapshot of the volume and then make a new volume from the snapshot. In the Azure portal, click on the data disk and it will load the page with all the disk's details. Click the Create Snapshot button at the top of the page. Name the snapshot instance Evidence and click Review and then click Create. Once the snapshot has completed, click the blue Go to Resource button. At the top of the snapshot page, there is a Create Disk button. Press it. Name the disk to be created Evidence-disk and ensure that the size is set to the same size of the source disk, which in this case is 4 GB. Now to attach the Evidence disk to the Forensic Workstation. In the Azure portal, select the Forensic Workstation VM. Then in the left-hand navigation menu, select Disks, and that will load the page with the disk's detail. This time, instead of clicking the Create and Attach a New Data Disk button, we will click the Attach Existing Disks button. In the Disks name field, start to type the name Evidence Disk, and it should appear as a selection. It may take Azure an inordinate amount of time for it to appear. Sometimes refreshing the page helps. If it never does, make sure your disks and the Forensic Workstation are in the same region as the test system. Click Save once the existing Evidence disk has been selected. In the SSH session to the Forensic Workstation, run lsblk and note that there is an unmounted SDC device with no partitions. Okay, now to calculate the hash. And the good news is they do match. And now for GCP. We're going to create a new project called HITC, and then we're going to launch 2 compute engine instances one at a time. We'll name the first one Test System, and then the other will be named Forensic Workstation. Put both instances in the same zone in a region near you. An E2 medium type is sufficient for our needs. To mix things up, let's keep the default Debian image. If you do not have an SSH key pair, run SSH Keygen to generate a public-private key pair. Expand the Management Security Disks Networking Sole Tenancy form and click the Security tab of that form and copy and paste the contents of the public key into the Enter Public SSH Key field. Be sure to set the username on the end of the string to the name you want to use authentication with. For this example, use HITC. SSH into both machines. In GCP, like with Azure, the hostname is already set for us. In the SSH session with the test system instance, run the lsblk command and observe that there's a single volume SDA with partitions. Now to add a data disk to our test system. In the GCP web console, click on the test system and its detail page will open. Click on the edit button at the top of the page and then scroll down to the additional disks section. This functionality operates similar to Azure. Click on the Add New Disk button, name the new disk data, set the size to the minimum, which is 10 gigabytes, and click Done to close the form, and then click the blue Save button to commit the change to the virtual machine. Back in the SSH session with the test system VM, run the lsblk command and observe the change. We can see that the new volume is SDB, and as with AWS, the volume has not been mounted and is not formatted. Let's do that and add our sample data as before. Next, we will unmount our new data volume to prevent any accidental changes to the volume and calculate its SHA-1 hash. And here's the results. Note that your hash will be different. In GCP, there are two different options. You can make a snapshot of a volume and then a disk from the snapshot, as with AWS and Azure, or there is a clone drive easy button. For consistency's sake, we will continue to make a snapshot of the volume and then make a volume from the snapshot. In the left-hand navigation menu of the GCP Cloud Console, click on Disks. This will load a page with all 3 disks that have been created so far. Click on the Data Disk to open a page with its details. At the top are various buttons including Create Snapshot, Create Image, Clone Disk. Click the Create Snapshot button. Name the snapshot Evidence and click the Create button. Upon completion, it will load the Snapshots page. Now click the Disks in the left-hand navigation menu. Click Create Disk at the top of the page that loads. Name the disk to be created Evidence and select Snapshot in the disk source type field. Select the Evidence snapshot in the source snapshot field. Important, in the size field, be sure to set the size to match the source disk. Then click the blue Create button. To attach the evidence volume to the Forensic Workstation in GCP, open up the Details page for the Forensic Workstation virtual machine and click the Edit button. Scroll down to the Additional Disks section, and this time click Attach Existing Disk and select the evidence disk we just created. Change the mode to Read Only and click Done to close the form, and then Save to commit the change to the virtual machine. In the SSH session to the GCE Forensic Workstation, run lsblk and note that there is a 10 gigabyte unmounted SDB device with no partitions. And now to calculate the hash. And notice that this hash also matches the SHA-1 hash from the test system. Well, there you go. We have demonstrated that the process to snapshot a virtual hard drive and to make a duplicate volume from the snapshot is a true forensic bit copy of the original volume, assuming that the volumes are the same size. We performed this test in AWS, Azure, and GCP, illustrating the technique with each cloud's user interface. If you have thoughts or comments on today's episode, feel free to chime in on the comments for this YouTube video. If you appreciate this video and want to see more like it, be sure to give it a thumbs up. Stay tuned for another installment of Head in the Clouds as announcements of new episodes are made on the SANS Cloud Security Twitter feed. Meanwhile, be sure to check out the other great videos in the SANS Cloud Security YouTube channel. Take care.